This specifies that the classification problem involves 5 distinct categories, numbered 0 through 4. This is crucial for understanding the scale of the problem and the resulting number of classifiers needed. 1 vs REST, OVR, is a multi-class classification technique. In this approach, a separate binary classifier is trained for each class. Each classifier is tasked with distinguishing one specific class from all the other classes. Think of it like having 5 separate judges each deciding if a submission belongs to their specific category or not. Hamming decoding is the method used to combine the predictions from multiple binary classifiers in the OVR strategy. It calculates the Hamming distance, the number of differing bits between the predictions and the actual class codes. The class with the shortest Hamming distance is selected as the final prediction. It's like comparing several possible answers to the correct answer and choosing the one closest to it. Logistic regression is the base estimator used by the output code classifier. This means that each of the binary classifiers in the OVR strategy is a logistic regression model. This is the underlying model doing the actual classification in each 1 vs REST comparison. This is the central question of the quiz. It sets the stage for evaluating the various statements about the output code classifier's behavior. In the specified scenario, it asks us to consider the number of models trained, the structure of the code matrix, and the decoding mechanism. Statement A presents a hypothesis about the number of models trained by the output code classifier. It suggests that the OVR strategy uses one logistic regression model per class. Statement B offers an alternative hypothesis, proposing that 10 models are trained. It's important to evaluate whether this is compatible with the OVR strategy. Statement C focuses on the code matrix, a key component of the output code classifier. It asserts that in this 5-class problem, the code matrix is a 5 by 5 matrix. Output code classifier is a technique for multi-class classification. Using the 1 vs REST strategy, it creates several binary classifiers. This OVR strategy, short for 1 vs REST, is a technique in multi-class classification. Imagine you have 5 classes of fruits: apples, bananas, oranges, grapes, and mangoes. In OVR, you train 5 separate binary classifiers. Each classifier tackles a single fruit versus the rest. One classifier distinguishes apples from bananas, oranges, grapes, mangoes. Another distinguishes bananas from apples, oranges, grapes, mangoes, and so on. In this problem, we're told that logistic regression is the base estimator. That means each of the 5 binary classifiers we just discussed uses the logistic regression algorithm to make its predictions. Logistic regression is a statistical model that calculates the probability of a data point belonging to a particular class. In our fruit example, it estimates the probability of a fruit being an apple given its features. Hey Vamsi, this line describes the core problem setup. We're using a special scikit-learn tool called _outputCodeClassifier. It's designed for multi-class problems, more than 2 options, and we're using it to classify data into 5 different categories, labeled 0 to 4. The OVR strategy, 1 vs REST, is a clever approach. We train a separate model for each category. Each model learns to distinguish that one category from all the others. This is the central question, Vamsi. It's asking us to think critically about what's happening inside the _output code classifier as it solves this problem using the settings we specified. This clarifies the 1 vs REST OVR strategy. Remember, we have 5 classes. OVR means we create 5 separate binary classifiers. Each classifier focuses on just one class, trying to separate it from all the other 4 classes. This is in contrast to other methods that might pair each class against each other class. Great, this shows the outcome of the OVR strategy. Because there are 5 classes, and OVR uses one model per class, we will have 5 separate logistic regression models. This is the core of how OutputCodeClassifier tackles this multi-class problem. The code matrix is a crucial part of how OutputCodeClassifier makes its final decision. Since we have 5 classes, this matrix will be 5 rows by 5 columns. Imagine it as a lookup table that helps OutputCodeClassifier decode the output of the 5 separate classifiers. It simplifies the combination of predictions into a final class prediction. Once the 5 binary classifiers have given their predictions, Hamming decoding comes in to figure out the final classification. It measures the difference, the Hamming distance, between the prediction outputs and the values in that 5 by 5 code matrix and assigns the class with the smallest difference. The Hamming distance essentially counts how many bits differ between 2 binary strings. Okay, let's break down this core concept. The OutputCodeClassifier uses a strategy called 1 vs rest, OVR. Imagine you have 5 different types of fruits. OVR creates a separate model for each fruit type. Each model learns to distinguish, is this a banana, versus, is this not a banana? It does this for all 5 fruit types. This is a fundamental part of how this classifier works, and it's what lets us handle multiple classes. We're dealing with a multi-class classification problem. This means we need to sort items into 5 distinct categories, labeled 0 to 4. Think of classifying emails into spam, work, personal, social, or promotions. The challenge is to build a model that can correctly assign each email to its appropriate category. The main task is to identify which of the given statements about how the OutputCodeClassifier solves this classification problem are actually true. It is a multiple-choice question, and we need to carefully examine each option. This statement links directly to the 1 vs rest, OVR, strategy mentioned earlier. Since we have 5 classes, the OutputCodeClassifier indeed trains 5 separate logistic regression models. Each model focuses on distinguishing one class from the rest. This is the essence of the OVR method. This option suggests that 10 models would be trained. This is incorrect. OVR trains 1 model per class, so with 5 classes, only 5 models are necessary. The other strategy is 1 vs 1 where for n classes n*, 2 models will be trained. This is not the case here. In this scenario, the code matrix is a 5 by 5 identity matrix. It's a 5 by 5 matrix because we have 5 classes. In a 5 by 5 identity matrix, each row represents a class, and a 1 indicates that class. This one hot encoded matrix is used in the decoding stage to determine the final class prediction. The Hamming distance is a measure of the difference between 2 binary strings. It counts the number of positions where the bits differ. The OutputCodeClassifier uses Hamming distance to determine the closest match between the predicted code and the code matrix, providing the final class prediction. This reinforces that 1 vs rest, OVR, trains 1 binary classifier for each of the 5 classes. This explains that a 1 hot encoding scheme creates a 5 by 5 code matrix for the 5 classes. The 1 hot encoding uses a binary vector of length 5 with only 1 representing the class. This clarifies that the Hamming decoding method is used to compute the final multi-class prediction. This is the final outcome of the process, assigning each input item to one of the 5 classes. This refers to the specific machine learning method used. OutputCodeClassifier is a technique that trains multiple binary classifiers to solve a multi-class problem. OVR, or 1 vs rest, is a strategy where each classifier distinguishes one class from the rest. Having 5 classes means there will be 5 separate binary classifiers trained. Since we're using the OVR strategy with 5 classes, we need 5 separate binary classifiers. The problem specifies that these classifiers are logisticregression models. Each model focuses on separating one class from the other 4. Code matrix is a way to represent the classes in a way that the OutputCodeClassifier can use. In an OVR strategy, this is usually a 5 by 5 identity matrix. Because it's a one-hot encoding, each class is represented by a row with a 1 in the position corresponding to that class and 0 elsewhere.